Our goal is to make a box plot. So please go to the main menu and create a new document. I'm trusting you can all see that. Okay, is that all right?
Yeah.
All right, so new document. List and spreadsheet. As usual, we're going to give our data a name. It doesn't matter what name you give it. I'm just going to call it, I'll call it height today. So once you've done that, I want you to type in a few numbers, 5 to 10 numbers. So I'll just type in 160, so some typical heights.
I love how Jesse and you swear to apply my accents, but this one yeah, that's right.
Okay, so I've just typed in about 5 numbers into the CAS calculator. Make sure you've got a name before continuing. And now you've got the laptop. Alright. And so now what you want to do is press Control I. And once you press Control I, a menu will come up giving you some options. This time you want to go to Data and Statistics, which is the fifth one. And what you want to do is hover your mouse over the bottom one that says click to add variable, and the name that you gave it should come up. So I call it height, so notice that height has come up as an option. So select that. Right now we've got a dot plot. The default is a dot plot. We're going to change this to a box plot. So go to Menu. First option, plot type. And the second option says box plot. And if you've done this correctly, you get a nice picture like that. Alright, so you know it, this one. Alright, so I'll just do a quick round to see how you do. Yeah, that's fine. You'll do that next time.
Yeah. Yeah. Is this it? Yeah, it is. But you actually have to leave just make sure the computer's turned on.
Okay, so Matt and Jackson, you're on the same stage. Now the menu. Let's watch one. Thanks everyone. We'll keep moving. So, we've just created a box plot on our CAS calculator. Now, I want to ask you as sort of as year 11, what do you know about these plots? Tell me everything that you know about them.
Squares.
Okay, so you say squares, we'll come back to squares. So Maddie, what do you
There's
say?
4 quartiles.
4 quartiles, okay.
It's a box.
It's a box. What did you want to say about squares?
They are squares.
Okay. Why? What's the point of making this picture?
So you can show the quartiles and the...
Great. So the box plot is a graphical display of our data. But unlike the dot plot or the stem and leaf plot, we don't see every single data point anymore. This gives us a better picture of what the spread is like in our data. Okay. I'm going to start with this and then do the box plot. So think of this as a warm-up question. Can I get everyone to open a page in their book and try to answer this question for me, please?
Wait, what did you say? Sorry?
Answer the question on the board.
What's my title?
Pardon?
What's my title?
Your title? This is a review of last lesson. The 2 lessons before. Yeah. So your title is box plots. Okay? So this stuff is going to be useful for us when you draw a box plot in a moment. That's your problem. Are you guys lost with this question? You're lost. Okay. All right. So I'll talk about it then. Okay. 5-number summary. Have you heard of this term before? 5-number summary just means these 5 numbers, okay? Sorry if I haven't explained that. I assume that you knew that from your 9 and 10. Okay, so I've given you the minimum, the maximum, the median, and the first and third quartile. So the first question I'm asking you is, what is the interquartile range? And I've abbreviated this as IQR. So you'll need to turn back a couple of lessons in your book to get a definition for the interquartile range. Does anyone have that ready? Maddie?
It's the third quartile minus.
Great. Okay, so if you didn't know that, take a mental note of that because you need this for today. Okay? All right. The next question might seem a bit strange if you've never solved a question like this. The hint that I'll give you is, what does the word quartile sound like? Quarter. Quarter means split up into 4. So if there are 4 quartiles, the middle ones being the median, Q1 and Q3, remember the median is like your middle. So what percentage do you think will be below the median, approximately? No? All right, let's take it back a step. What percentage will be between the first and second quartile? So I've broken.
15.
Where'd you get 15?
Well, for the minimum, it would be 15, wouldn't it?
Where'd you get 15 from?
Down below, it says minimum 15.
But I want a percentage though.
Oh, 25%?
Okay, see the top row here? I've drawn 4 arrows. So the quartiles, Q1, Q2, or the median and Q3, they're breaking up the data into fourths or quarters. So so 25% is correct. You're going to have 25% between the minimum and Q1, 25% between Q1 and the median, 25% between the median and the third quartile, and 25% above the third quartile. So remember, 25% is 1/4. Okay, 1 in 4. Does that help? Okay. Where is 28 in my 5-number summary?
Median.
It's the median. Okay. So now that I've told you that 28 is the median, what percentage is going to be below the median? The median is in the middle. So how much of my data is going to be to the left? Yeah, so I'm saying below the median, so this part of the data. Okay. Remember, the median breaks your data set into half. All right, 21. Where is that in my 5-number summary? Q1. Again, look at the diagram. What percentage is between Q1 and the median? 25. All right. You starting to get this now, or have I still lost you? Okay, Q1 and Q. Okay, so 21 is Q1, 33 is Q3. So now I'm looking at what's between Q1 and Q3.
50%.
That's right. I've got two 25% in between Q1 and Q3. So the answer is 50%. Where else did I use the numbers 33 and 21? That's right. So if you're wondering what is this interquartile range about, it's the middle 50% of your data. Hopefully you can see that in this diagram here. It's the middle 50%. And last one, what percentage is going to be below 33, which is Q3? 75, because now I'm looking at Q3 and which numbers are smaller. So I'm going in this direction to the left, and I've got 3 25s giving me 75. Okay. We can review this again next lesson. I would say this would be a hard question for some of my Year 12 students as well. So don't worry if you're feeling this is a bit difficult. It'll come with some practice. All right. We're looking at box plots now. The reason why I got you to do that previous exercise was because if you understand what the quartiles mean and where that 25% is, you will always see that when you're looking at a box plot. So the first thing I want to do is remind you what the lines mean on a box plot. Yes, so normally when you're going from left to right, you've got the smaller values on the left and the larger values on the right. Where's Q1 on this diagram? Did you learn this in year 9? No. So this is all new stuff. Okay, so I'll just give it to you, okay? Oh, interesting. Okay, thank you for telling me. All right, so Q1 is the value to the left. Q3 is the value to the right. That's right. So in every box plot, you're going to have a box and a line going through the middle of the box. This line here is the median. Okay. So because this is new to most of you, I would suggest you get this down. I will expect you to draw some box plots for me on the test. And I will give you some box plots to read as well. All right, are there any questions so far? All right, so hopefully you've got the diagram down. Okay. Remember what we just did about the 25% parts of a data set? Do you remember a long time ago, I asked the question, is the data symmetric, positively skewed, or negatively skewed? So you remember that question? It's actually a lot easier with a box plot. So think about, how do we define positively skewed? Say that, Jess.
What if it's going in like the positive way, not the negative?
So what? So when you say going in the positive, what exactly do you mean?
It's going uphill, not down.
Uphill?
Is that right? Well, which direction? Yeah, the direction it's going in. Left or right? Yeah.
So this one is positive, and this one's negatively skewed. All right. So in that lesson, I explained that positively skewed data has a larger spread in the positive direction. So here, the positive values, the larger values, are more spread out. Yes, because remember, you've got 25% here, and you've got 25% here. So in the positive direction, the data is more spread out. So this one's actually positively skewed. Okay. All right, we're going to add more features to our box plot. So if you just give me a moment, I'm going to clone this page, and we'll add more stuff to it. Actually, no, I'm going to create a new one. All right, so I want you to draw a new one in your book. All right, so let's review. What's this line here? Q1. This one? Median. And this one? Very good. All right. See this arrow here? What have I represented with that arrow? Not quite the range. The range is different. The range is the maximum minus the minimum. And the maximum is out here. But it's very close to the range. We just need to add a couple of words before it. Something, something, interquartile range. Remember? IQR is Q3 minus Q1. So if I draw an arrow between Q1, which is here, and Q3, which is here, that's the interquartile range, which I represented there. Okay. All right. Let's look at the dotted lines. So you don't actually draw the dotted lines, but you calculate them. So
These dotted lines are called the upper fence and the lower fence. So get that down. Have you heard of the term outlier before? You have, no? Do you have an idea how you might explain it? It doesn't have to be maths related. What would you describe as an outlier?
Value can outlier to the IQ of the class. In a good way.
In a good way. So Jai's off the charts, you see? Okay. So very, very different. So often, a good example is usually there's someone really tall at the school, and they might be so much taller than everyone else, you might just consider them an outlier, just so different from everyone else. So when we draw a box plot, you'll often find that there's a box, and on the side, we call those flat lines the whiskers. So sometimes you'll hear it called a box and whisker plot. And some of you might have found that there were dots to the left and right of your CAS calculator plot, depending on what values you put in. So the main focus of today, once we've established the middle part, which is Q1 and Q3, we need a way to decide whether data is unusual enough or far away enough that we would consider it an outlier. So I'm just going to give you the definition, okay? So a data point is considered an outlier if its value is below the lower fence or above the upper fence. And you will also want to write this down. The lower fence has a formula which involves the interquartile range. So the lower fence is Q1 minus 1.5 times the interquartile range. And the upper fence is Q3 plus 1.5 times the interquartile range. All right, so make sure you've got the black writing down. If you intend to do Year 12 General Maths next year, you must know how to interpret a box plot. And given that you didn't do this in Year 9, then I'd say you need to pay very close attention to today's class. All right, can you just give me a nod once you finish writing? I'm going to add one more thing in orange. Sorry about this. So that value is the largest value, which is not an outlier. and this is the smallest value, which is not an outlier. Oh, okay. So, in this course, we expect you to be able to make a box plot on the CAS calculator and to be able to make one by hand. So just today, we will do one by hand, but most of the time we will do it with the CAS calculator. But there may be times where I give you some of the information like Q1, median, and Q3, and I ask you to just draw the box plot for me without the raw data. All right, can I move, or is anyone still writing? All right, just copy off the person next to you if you're still writing. All right, so let's do this with an example. So I'm going to give you some data, and I'm going to set it up so that there is an outlier. Okay, you can probably guess that the number 5 is going to be an outlier because it's really far away. Okay. All right, so what do we need to draw a box plot? What statistics do we need?
Do you have to order them first?
Yeah, great question. Yes, so before you do your statistical analysis, you want to put it in order. I've already put it in order for you. All right. So what numbers do we need for the box plot?
Find the median,
All right, we need the median.
which is 59.
Yep,
And then the first quartile, whatever it's called, and the maximum and the minimum.
great. Okay, so we've done this multiple times. If you're rusty on this, just let me know and I can catch you up. All right, we don't actually need the minimum or maximum because it's already there in the data set for us. So, in order to draw this box plot, I'm going to need to calculate the interquartile range. Why do I need the interquartile range? Look back on your diagram. What part of the box plot depends on the interquartile range? So the interquartile range is the difference between Q1 and Q3. But why is it worth calculating this? To find the outliers, yes. Okay, so if you didn't catch that, guys, one of the things that we need to decide when we're drawing a box plot. So Maddie and Tyler, look up here. See these dots on the sides here? Those are the outliers. But when I just have the numbers like this, I don't know which ones are outliers. So I need to decide whether I'm going to include all my data. Huh? So outliers are we think that those data points are very different from the rest. So we're going to represent them individually like this. Okay. So like you might have 500 data points here, and then like 2 out here. So rather than having the whole thing stretched out, we want to represent the fact that just only a small number are out there. Okay. So if you look at your diagram, you'll see that an outlier is either below the lower fence or above the upper fence. And to calculate the fences, we need the interquartile range. So I'll do that now. The interquartile range is Q3 minus Q1. Which is 16. I think I'll just do this calculation for you. So the lower fence is Q1 minus 1.5 times the IQR, which is 56 minus 1.5 times 16. So I've calculated the fences. So any number below 32 or above 96 is an outlier. See how I needed to use the interquartile range to get that?
How did you get 24 when it was box 32?
56 minus 24.
How did you get 24?
1.5 times 16 is 24. I'm pretty sure it is. It's half of 16 is 8. Yeah, you can check it if you want. So, based on that last sentence which I've written there, are there any outliers in the data set? Which ones are the outliers? Yep. The outliers are... Yeah. Okay, so when you draw your box plot, you'll need a scale. So in the middle of the box plot, I will need 3 lines. One for Q1, one for the median, and one for Q3. So the median is 59, so I'll put a line here. Q1 is 56, so I'll just move it slightly over. So this hasn't turned out the way I wanted. And 72 will be here. That's my box plot here. Okay. Now, how do I represent the outliers? Do I draw a line to the outliers? What did we do in the last diagram? No? Lost you? Okay, the outliers are the dots. Okay?
So you put a dot on them?
Yeah. So that's a dot for 5. And this is a dot for 106. Okay, I should apologize because this example has not worked as I wanted. I wanted to have some lines coming out here as well.
Wait, why do the lines come out there?
Yeah, so there's actually no lines here. So the reason is, if you look at this orange text here, I'm looking for the largest value, which is above Q3, that is not an outlier. And over here, I'm looking for the smallest value, which is not an outlier, which is below Q1. And I don't have any such values, because as soon as I go from the quartile, I'm already at the outlier. So to do this example better, what I should have done is use a few more data points. That's okay. Let's do another example. And this time we'll just have one outlier. So 9,000. I can't draw it on the box plot though, with a scale of 10. Okay, 90. Is that good enough for you, John? Clearly, we've got a Digimon fan in here. Okay, this time, what I'd like you to do is to get Q1, the median, and Q3 using your CAS calculator. Okay, you should know how to do that. So just chuck the data in, and this time get Q1, the median, and Q3 using the CAS calculator. I'll try to do it quickly here, but I might make a mistake. I'm just counting how many points there are. Yeah, so you don't need to worry about that. Okay, so this example is going to work. So because of the outlier, I need to have quite a large scale. Did you get the same Q1, median, and Q3 as me with the CAS? Yes? No? Yes? So you did it on the CAS, and you got these numbers?
Well, no. Because we don't have access to it as calculator, we use our calculator.
Okay. All right. So I've done this by hand. Those of you who've done it on the calculator, you'll be able to tell me whether I've done this correctly or not. So I've done this mentally. It's a lot easier on the calculator. So I think the first quartile is 16. So I should have a line at 16 to the left of the box. Then 21 for the median, which is the middle line, and 26 for Q3. Okay? Now, this time I've got whiskers. Not literally me, but the box plot has whiskers. Okay? So please make sure you get this box plot down. I need to draw a line to the smallest value. Guys listening? So I need to draw a whisker to the values which are smaller than Q1, which are not an outlier. Do I have any outliers in this data set? Which one? Okay. Okay, this is the only outlier because it's above 41. There are no data points below 1. Okay, so this value here is going to be 10. So my left whisker is going to include all of the data. Now on this side, I need to draw a whisker to the largest value, which is above Q3, which is not an outlier. So which data point is that? 34. Okay. So notice I am not drawing the whisker all the way to 90. How will I represent the outlier? Thank you. Okay, so do you think you would rather do this on the CAS calculator or by hand? Well, that's a viable option too, but you're stuck with this course for now. Yeah. With the CAS calculator, you just need to type the data in.
Wait, so why are we actually learning this? I'm so confused. Like, are we going to use it? School? But what if you don't need them? Other than that, this is for learning and for tests. Can you please go back? I think this is
Yep. Can you wait till Can you wait 5 minutes? If you're busy, then just go. You like if you need to go, just go. All right, Tara has asked a good question. Why are we learning this? All right, I've had this question multiple times from my Year 12 class. So I have a strong suspicion that 90% of the stuff that I teach you, you won't use after you leave school. So some of you might use a lot of the maths, some of you might use very little. It all depends on what you do after school. So if you go by the principle, we should only learn things if you're going to use them after school. It's going to be very hard to teach a class because everyone has different needs. Everyone's going to different places after school. Are there any subjects that you can think of that you're doing for fun, which you might not use after school? Construction. Right? So I imagine that when you're in studio art, you're not thinking this is a waste of time, I'm never going to use this after school. You're enjoying it, right? No. Oh. I'm sorry to hear that.
It's either art, construction, or water.
So I thought you did art because you liked it. Yeah. So I'm really sorry to hear that because sometimes I wish that at school we would just pick subjects because we liked them because they were fun. We wouldn't worry about whether we were using them after school. So, for example, I'm not really a sporty person, but I liked PE because we got to go outside. We got to play games. We didn't have to sit in a room for 2 hours, listen to someone drone on. But I didn't ever ask, when am I ever going to use PE? I just enjoyed the class because it was fun. Math may not be the most fun subject. I mean, I've got my whole lifetime to work on it. So let me quickly try to give you a reason why you might use this after you leave school. Yes, Ash? Yes, you can. Yeah.
Wait, do you only teach maths or do you teach another class too?
I'm technically allowed to teach physics. Yeah.
Well, if you're allowed to teach physics, like technically, at some point that's something that is
I have heard rumors they might try to get me into physics next year, but they're rumors. Yes. Did you want to go as well, AJ?
No, I just tried to help him for this.
Okay. All right. Okay, let me show you something with box plots. Actually, I'm gonna open it up on my computer. Okay. So I showed this to my Year 8 class last year because we did box plots then. So let's see. Box plots. All right, so this is it. So I'll tell you a brief story, and then I'll let you get some work done. So guys. All right, so um, you may not know. So Mrs. Kidd used to be head of maths at this school. Jesus is invincible. I thought she still was. Mrs. Machete is in charge of maths. So a number of years ago, Mrs. Kidd brought about a change in the way maths was taught in the junior years. So they're all on the whiteboards now, doing something in groups. Yeah, so they don't have a textbook in year 7A. So that was a change that was brought in. You might wonder, why did they bring in this change? So a lot of this work, I mean, textbooks are boring, right? Unless you are already interested in maths, you're not going to find a maths textbook very interesting to read. So, Joe Bowler is this really famous maths educator.
What is his last name?
It's a she, Joe Bowler.
John.
Joe.
John. I thought you said John. I was like,
Yeah, so I'd like you to listen to this. So, Joe Bowler did a study. So she did what would be done now in the junior years of maths at this school. So she studied two schools. One school did the traditional textbook work. The other school, they did the modern cooperative problem-solving group work stuff. Okay, so this is what the classes were like before they had the teaching. Okay, so the traditional school was here, and the rail side, the modern stuff, was here. So which school was better off at the beginning? Okay, you can see the middle 50% is higher up, and here they are further down. Okay, so this is before they started teaching. Now we do the teaching.
I'm confused.
Mm?
Yeah, so never mind.
Okay, so above is before, and below is after.
Why are they in a higher if no one's been teaching them yet?
No, it's like this is like your pre-test.
Oh,
This is your post-test.
they have been teaching it, but it was more traditional than whiteboard, and then
Yeah. Okay. Pre-test, post-test. Traditional in blue, modern in red. So this is actually quite a lot to read, but have a look at the bottom box plot. What's happened after the teaching?
it got good.
How so? There's a gap initially. Yeah, so it looks so. See, this is Q3 here, guys. I don't think you're listening up the back. So Q3 and Q1 are there. Oh, how do I get rid of that? Oh well, Q3, Q1. So can you see before they started, Q3 was lower in the modern group, and what's happened after the teaching, Q3 is actually caught up. So before they were behind, and now they've caught up to the traditional teaching method. So a box plot is just a really easy way to show how two groups can be. So I'll start that again. A box plot provides a very easy way to compare two groups. You just draw the two box plots side by side on the same scale. Okay. So if you're not going into science or psychology or stuff, you probably won't use box plots much. But if you are going down that path, then you'll see these all the time. I have a strong suspicion that at some point in your life you will read a newspaper or watch a news segment where a box plot is shown. So I do hope that you will remember at least something of what we talked about today. Maybe not all the names, but at least what the picture is showing you.